Hi guys, today we will learn Chapter 6, Interface and Communication. The content in this topic, we will discuss about the internal device, input-output interface module, interrupt, DMA, synchronize, and asynchronous. This is example of the input and output. We have printer, we have scanner, monitor, audio system, mouse, stick, DVD drive. Input device. Input a signal or data received by the system. For example, keyboard, mouse, scanner, game controller. Output. The signal or the data sent from it. Monitor, printer, disk drive, floppy drive, modem, network interface card. This example input and output. Okay. General description of input output. Wide variety of peripheral, delivering different amount of data, different speed. Input-output module are the third critical element of the computer system. All computer systems must have efficient means to receive input and deliver output, all slower than CPU and RAM. Input-output module. External devices are not generally connected directly into the bus structure of the computer. Input-output act as interface for an external device, peripheral, to CPU and memory via system bus. Interface to one or more external device by link. Closing the gap. Why cannot we connect peripheral directly to CPU bus? This is why variety of peripheral does require different control logic, different data transfer rate, different data format and word length. And then input-output module to act as bridge between processor, memory bus, and peripheral. External device. Exchanging data between external environment and computer, also known as peripheral device. Human readable, suitable for communicating with computer. Example, screen, monitor, printer. Machine readable, suitable communicating with equipment. Example, magnetic disc and tape system. Communication, suitable for communicate with remote device, for example, modem, network interface card, sensor, and actuator. External device. The interface of the input-output module is in the form of control, data, and status signal. Control signal determine the function that the device will perform, read or write. Data in the form of set of bit to be sent to or received by input-output module. Control logic. Associate with the device, control device operation in response to direction from input-output. The transducer convert data from electrical to other form of energy during output and form to electrical during input. Control logic is input-output module interface to the device. The data channel pass to the collected data from the data to be output to the device. The transducer acts as a converter between the digital data of the input-output module and the signal of outside world. Keyboard convert motion of key into data representing key. Temperature sensor convert amount of heat into a digital value. Keyboard is a keyboard or monitor. The most common main computer and user interaction is keyboard and monitor. The input is then transmitted to the computer and may also be displayed on monitor. ASCII. The top row being MSB, where the first column being LSB. Example, character K is 4B or 1001011. The major function for input-output module, control and timing to coordinate the flow of traffic between internal resource, main memory, system bus, processor communication, communicate with processor in terms of accept command from processor, read, write, exchange data, status reporting, busy, ready, and address recognition. Device communication, communicate with external device. Data buffering, temporarily hold data between being transferred between input-output module and external device. Error detection, detect error and report error to the processor. CPU communication, communicate with processor in terms of accept command from processor, read and write, exchange data, status reporting either busy or ready, and address recognition. Command from processor, the input-output module accept command from processor typically send as a signal. Data, exchange data between processor and input-output module over the data bus. Status reporting, peripheral are slow, those need to check the status through input-output module. Address recognition, input-output device is set up as a block of one or more address unique to itself to allow referencing. Module structure. The module connect to the rest of the computer through a set of system bus line. Data transfer to or from a module are buffered in one or more data register. One or more status register provide current status information. A status register may also function as a control register to accept detailed control information from the processor. The logic between module interact with the processor via a set of control line. The processor uses the control line to issue command to the input-output module. Some of the control line may be used by the input-output module. Instruction. We have address and input-output command. The address specifies the particular input-output module and external device. Input-output command, we control, test, read, and write. Memory mapping. Single address space for memory input device. Processor treat the status and data register of input-output module as memory location. Use same instruction to access both memory and input-output. For example, 10 address line to multiple 10 memory location plus input-output address can be supported. Instead of having special method for accessing the value to be read or write, just get them from memory or put them into memory. The device is connected directly to certain memory location. Two types of information to or from the device, status and value read or write. Why use memory mapping? Map programming simple, do not have special command to access, take some memory location, very few compared to the size of main memory. Difference between isolated input-output and memory mapping. Isolated input-output. Isolate input-output use separate memory space. Memory map input-output. Memory map input-output use memory for main memory. Isolated limited instruction can be used to set in-out instruction output. The address for isolated input-output device are called port. Okay, memory map I/O. Memory map I/O device are treated as memory location on the memory map. IORC or IOWC signal has no function in this case, which reduce the circuit. Technique of input output. Program input-output CPU has direct control over input-output. The processor executes a program that gives it direct control of the input-output operation. When the processor issues the command to the input-output module, it must wait until the input-output operation is complete. Interrupt driven. The CPU issue command to proceed with its normal work until it interrupted by input-output device. DMA. The input-output module and main memory exchange data directly without involvement of CPU. Okay, technique of input-output memory transfer, no interrupt, program input-output, use of interrupt driven input-output. Program input-output. CPU has direct control over input-output, sensor status, read-write command, transferring data. CPU wait for input-output module to complete operation. The processor is faster than input-output module. This waste of CPU time. Program input-output detail, CPU request input-output operation, input-output module set status bit, input-output module does not inform CPU directly. CPU may wait for come back later. Program flowchart. Processor request operation with command send to input-output module. Okay, control telling the peripheral what to do. For example, spin up this. Test. Used to check condition input-output module or device. Either error or power error. Read. Obtain data from peripheral so processor can read it from the data bus. Write. Send data using the data bus to the peripheral. Input-output module perform operation when complete input-output module update its status register. Input module is not inform CPU directly. Waste CPU time because typically processor is much faster than input-output. CPU act as a bridge for moving data between input-output module and main memory. CPU wait for input-output module to complete operation. Interrupt driven. Overcome CPU wasting time, processor issue input command to a module and then go on to do some other useful work. The input-output module will then interrupt the processor to request service when it's ready to exchange data with the processor. The processor then execute the data transfer as before and then resume its formal processing. Require setup code and interrupt service routine. No repeated CPU checking of device. Input-output module interrupt when ready. Still require CPU to be go between for moving data between input-output module and main memory. Okay, interrupt-driven program input-output require active CPU intervention. Transfer rate is limited by processor ability to service the device. CPU is tied up managing input-output transfer.